So we will continue from the previous where we stopped before we are timed out. Okay, I will share its screen. So we're looking at counting rules. Counting rules. We have the fundamental counting rule, permutation and combination. Now let's look at this one. Fundamental counting rule. In a sequence of n events, according to this rule, in which the first one has k1 possibilities. 1 minute, let me admit this. And the second event have k2 possibilities. The third event have k3 possibility, and so on. Then the total number of possibilities would be k1 times k2 times k3. Or you keep multiplying until you get to the last event. Yeah. So let's see how this works. Let's see how it works. Now look at this place. Okay, a coin is tossed, and we'll move it down so we can have room. A coin is tossed and the die is rolled. Find the number of outcomes for the sequence of events. Solution. A coin is tossed. For a coin, you know, a coin has 6 sides. So coin is your k1, okay, equals 2 sides. Now for dice have 6 sides. So dice equals k2, okay, 6 sides. So number of possibilities, okay, number of outcomes on possibilities will now be multiplying the two of them, k1 times k2. So have remember this is k2. Okay, I'm gonna make it. So number of possibilities will be k1 times k2. Number of outcomes will become k1 times k. That means 2 times 6. 2 times 6, which is 12 possibilities. This one is so easy. A caveman can do this one. Any question on this one?
Yeah, Professor.
Yep.
Sorry, I just came in. I don't know what I've missed.
We're just starting actually. We introduced fundamental counting rule. So you say that a coin is tossed, the die is rolled. Find the number of outcomes for the sequence of events. So we the formula is k1 times k2 multiplied by the number of events that you have here for a coin. We have a k1 as, because coin have 2 sides, so k1 is 2 possibilities. Die sides, 6 possibilities. So total number of outcomes is k1 times k2. That means 2 times 6, 12 possibilities.
Okay, thank you.
Next one is the application. I like to use application because I believe that theory is practice. It says here, a paint manufacturer wishes to make several different paints, and these are the categories: color, red, blue, white, black, green, brown, yellow, type, latex, oil, then texture, flat, semi-glass. Please use outdoor, indoor. It says, I think I missed how many? I think I missed something here. Give me 1 minute. I missed something. Let me type it. It says, how many different kind of paints? How many different kinds of paints, okay, can be met if a person I can select one color, one type, one texture, and one use. That's how many different kind of paint can be made? A person can select one texture. So now, let's start with color. Let's say that color is our K1. How many colors do we have? That can tell us.
7.
So 7 colors. Yeah, K1 is 7. So that K2 can be K2 can be 5. And we have 2 types, latex and oil, right? 2. K3 will be the texture. 3 of them. 3. So we have K3. And then K4 can be
2.
2 of them. 2. Okay. So that they are how many kind of paints? Okay. Number of paints that can be made. So total possible different paint, total number of different paints equal to K1 times K2 times K3 times K4. And that will give us the answer right away. Okay. All right. So that we will have 7 times 2 times 3 times 2 different types of paints. So we're gonna go and multiply this. Where's my calculator? So this gives us 7 times 2 times 3. 2 times 3 times 2. 84 different kind of paints. We got 84 different kind of paints. 84 different kinds, okay? Question? Any query? Okay, no questions. So, excellent. Now let's do the last one on that section. Then we can now finish up with permutation. Here, units, the digit for that are to be used in a 4-digit ID card. Please mute yourself. As shown here. How many different cards, if possible? How many different cards are possible if repetitions are permitted? Repetitions are not permitted, and repetitions are permitted, but the digits cannot be 0 or 1. Now, remember, this is a card, ID card, 4-digit ID card. So that means there can be 4 slots. This is the first slot, the second slot, third slot, fourth slot, 4 slots. So if, now the first one says repetition are permitted. That means these numbers, there are 5 numbers, 1, 2, 3, 4, 5, right? So you can use 0 in any of these slots and many times you want. You can use 1 in any of these slots many times, and so on and so forth. So there are 4 digits but 5 numbers. So number of cards for the part A, cards may be 5 times 5 times 5 times 5. Why 5? Because there are 5 digits to choose from, but there are 4 slots. So you stop on the 4th one. So you stop on the 4th one. I'll give you 6 25. Okay, that's 620. Sorry, my mistake. If you multiply this, 5 times 5 times 5. So you got 5 times 5 times 5. 5 times 5 times 5 times 5. 625 cards, correct? Okay. 625 cards. For B parts, it is a little bit different. It says repetitions are not permitted. So in this case, if you use 0 for this slot, you can never use 0 from this slot anymore, but you can use it here and here. If you use 1 on this slot, you cannot use it, or if you use any of this slot, it cannot be repeated in the same slot. So that means it decreases. Each of the number decreases after each use. So that's the number of cards will be keep declining. 5 numbers, 5 times 4 times 3 times 2. So 5 times 4 times 3 times 2. Okay. 5 times 4 times 3 times 2. 120 cards are possible.
So, Professor, I have a question. We're using 5 because it's 0, 1, 2, 3, 4, 5?
Yes.
Okay.
And you stop on the 4th multiplication because you have only 4 slots. Yeah?
Okay.
As C says, repetitions are permitted, but the first digit cannot be 0 or 1. So in this case, you can repeat like you did on the first one. However, the first digit, the first slot here, first digit cannot be 0 or 1. So that means there are only 3 numbers, 3 this thing left for the first 3 numbers. Actually, can be 0 or 1. So there are only 3 numbers left that can be used in the first digit. See? So that means number of cards, it become, for the first digit, is 3 numbers for that, because you can use 0 or 1. Then the rest is 5 times 5 times 5 times 5. So we got 3 times. Okay. 3 times 5 times 5 times 5. 375 cards. Cards. Questions before we go to the last section? Okay. Excellent. Now look at factorial notation.
Excuse me. For the C part, the question says 0 and 1 cannot be used. So,
0 and 1 cannot be used in the first slot.
okay.
First digit. So only 3 numbers left for that first digit.
Yeah, what I want to clarify is that only 3 numbers is left, but we still have to repeat the numbers of times the cards can appear. We still have to keep to the 5. We cannot
because the other digits can be any number, but for the first digit, only 3 numbers is left for that. Only for the first digit, the rest stays.
So for number C, and well, for letter C, instead of using all those 5s, we could have used 3 times 2. I don't know how you got all them 5s. I don't understand that.
Same 5. 1, 2, 3, 4, 5. Right?
Yeah.
But for the first law, this one, you cannot use the number 0 and 1 in this only for the first slot, which means that you have only 3 numbers for that first slot. The rest of them, you can use all the 5 numbers.
Okay.
That's why the first one is 3, the rest are still 5. Okay? All right. So the factorial notation. Factorial, if you look at it, you can, if you see the N and the, in English language, we call this exclamation mark. Am I right?
Yes.
But in statistics, it's called a factorial. So it means N times N minus 1 times N minus 2. So it keeps decreasing. For example, if I say 5 factorial, what it means is 5 times 4 times 3 times 2 times 1. So that gonna be 5 times, okay, 5 times 4 times 3 times 2 times 1. 120. Okay. 120. If I say something like 8 factorial, 8 factorial, it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which we can get on the calculator as follows. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 40,320. 40,320. Yeah. Now, and so on and so forth. So that's what it means, factorial. Now, so that when you see that thing, there's that symbol with this exclamation mark, you know that it's talking about factorial notation. Now, let's apply. See how.
Sir, can you please follow up? Thank you.
Now, let's see how it can be applied. Now, say the one we call permutation. Permutation is the arrangement of n objects in a specific order. And this is the formula here. So some calculators have this, how to, you can get it from calculator right away. For this class, we'll be using calculator, excuse me. But you can see the factorial number, factorial function here. And it's at the bottom. So when you see them, you know what it is. I encourage you to practice it if you have the textbook. But I can show you how to get it using a calculator. That's what we need, because you're gonna apply it in something even bigger than this. So we have let's see how we can use that. I can see the first one, solution. Now it says 12 permutation 3. That's part A. 12 permutation 3 equal. It means okay. It means 12 factorial. 12 factorial divided by 12 minus 3 factorial. So, but like I said, this is, if you want to get it, use it by solving it manually. Otherwise, like I said, for this class, we'll be using calculator. What we need here is that we know that for this one, our n is 12. Our x is 3. So when we plug this in, we can get the answer that we want. 12 permutation 3 under this. You can get it from the calculator right away. Becomes, let me take you there. For this calculator, we have the you can use the function. They use R for X. So you click on it. Just 12, comma 3. I'll give you the answer right away. 1320. 1320. 1320. That's the answer right there. Question?
Sir, please, how do we do it manually?
Manually, you gotta find the factorial for n. So you gotta do you're gonna do n times. You're gonna do n times. That means n is 12. So you gotta do 12 times 11 times all the way to the last number, then divided by what you have, 12 minus 3. 12 minus 3 is 9, right? We have a 9 times 8 times all the way to the last one. That will give you the answer. Yeah, that takes a longer time. So I encourage you to use the calculator to get it. But if you are doing algebra, at the algebra level, I can say, okay, go and start working this, but you're not in statistics, so get it with calculator. Yeah.
I have a question. The n minus x would be
9. That's how you get this 9.
the 9. So all the way,
So
you would take it all the way down to 1?
Yeah.
So then what would be the x? The 3?
X is a 3. So that means
Okay.
9 minus x and 10 minus 12 minus x. That means 12 minus 3. I'll give you 9.
Okay.
Yeah, x is 3.
Okay, so then after you do this, that would replace.
Then you divide.
All right.
But like I say, use calculator because when you start doing binomial, you don't have time to start doing all this. Yeah. All right. Let me do another example before we you see, it says 6 permutation 4. Let me do B. 6 permutation 4. I have, in this case, n is 6. Okay, and x is 4. So that's 6 permutation 4. Permutation 4 become okay. I go to your calculator. Okay, every calculator have this. Every scientific calculator have this. Okay. So clear this. See the functions. You can see MPR. Click on that. 6, 4. That gives the answer right away. 360. 360. 360. Okay. Now you can practice this at home. Let's apply this to one example. It's a TV director wishes to use 3 news stories on an evening show. One story will be the local lead story, one will be the second story, and the last will be the closing story. So you can see that it's an order. Remember, permutation is the arrangement of an object in a specific order. So you can see that this question refers to permutation because there's a specific order. One story will be for local story, local lead story. The one will be for the second story, and the last will be for the closing story. So there's a specific order. That tells us that permutation is good for this. So if the director has a total of 8 stories to choose from, how many possible ways can the program be set up? Have solution here. So here, how many stories it had? It had 8 stories. So our n equals 8. 8. So n. Now you're gonna use there are 3 new, but she has 3 new stories to choose from. So that means our x equals 3. So So how many possible ways? Number of ways will be 8, permutation 3. Okay, which will be 8 permutation 3. Make it big. 16 should be good enough. That means 8 permutation 3. So you go to your calculator and you will see P. Okay, clear this. 8, 3. 336 ways you can choose from. So this will tell you so we have how many? I forgot the number of the components of a DNA. I think it's DNA. You can see they can combine in different form to produce a different kind of individual with a totally different personality. Because this they can combine. So even though there are, I think the components of DNA, there are about 5 of them, I believe. Those of you in biology, we know what I'm talking about. So that's what it is. So now, when we are looking for any question on this one, any question at all?
Yeah, I have a question. The X is equals to 3. Where does the 3 come from?
But the director wishes to use 3
new stories.
New stories. That's how the 3 came from.
Okay.
Now, a selection of an N object. In permutation, there will be a specific order, but in combination, there's no regard to order. Okay. So in that case, we use this formula. Again, I encourage you to practice it if you have a chance, but to be you can see the factorial notation here, right here. So it's in both of them. So that if we have let's say we have the first one, we have a 7 combination 4. Maybe let's say at A, if you write it out, I will show you how it will look like. You plug it in, make this up to 18. Why is it not looking like that? Okay. Yeah, let me see. Okay. So we have part A, have 7 combination 4. In this case, N is 7, X is 4. Let me show you how this will look like when you put it in the formula. So let me take you to this workbook. Okay, so that's 7 combination 4. Okay, let me put it this way. Combination 4. It look like this. You know what I'm gonna do? Just give me 1 minute. 7 combination 4 will be okay. Well, I missed it. I think I missed it. Okay, give me 1 minute. I want to show you how it will looks like. 7 combination 4. Okay, 7. I'm gonna put it there. 7 combination 4 will look like this. Okay. 7 factorial divided by 4 factorial times 7 minus 4 factorial. See? So which is equal. Now, this is how it will look. And then if you go to the calculator and put it in that case, we're using C. 7, this is NCR. R is for X here. So 7, 4. Give you 35. 35. About 10 minutes left. 35. 35. Okay. Paste it here so you can see it. So the answer will now become 35. See? Now, so just once you get your N and X, put it in the calculator and it will give you the answer right away. So that if we have part B, at B will be the 20 combination 5. So N is 20 and X is 5. So that's 20 combination 5. It becomes if you plug it in, you're gonna be 20 factorial. It will look like this one, but here will be 20, and here will be 5. You know, so let's get the answer right away. So I make it a little bit big. Yeah. So that will give us you can see the screen, right? You can also see the screen, right?
Yes.
So that means we go here and see 20, right? And see 20 comma 5. I'll give you the answer right away. 15,504. 15,504. 15,504. Now, let us look at the application, how we can use this in real life. Remember, combination, there's no regard to order. Suppose this say a bicycle shop owner.
Sir, can you go back to the question?
Take a picture of it.
I'm done. Thank you, sir.
A bicycle repairer has 12 mountain bikes. 12 mountain bike in the showroom. The owner wishes to select 5 of them to display as a bicycle show. How many different ways? So there's no specific ways. There's no specific order. So solution. I'll have 12 mountain bikes. So our N is 12. N is 12. And have to choose, the owner wants to select 5. So X is 5. Yeah. So in how many ways? It's gonna be 12 because there's no specific order. Combination 5. So that, well, let's make it big. Already big. So you got the 12 combination 5. This looks like this is how it looks like. It means 12,5. Or you can use the formula if you want. 12 combination 5. So when you don't worry, our next topic, which will continue till tomorrow, we do after our last, when we do binomial, you understand why I said to use calculator, because you won't have the time to start getting all this doing the math part of it. 12,5 have 792 ways to do the selection. 792 ways. Okay, ways. Questions? So we have finished probability theory. We're still going to meet probability theory, but in different form. We'll do probability distributions, which will be our next topic. The probability distributions. So this let's I'll have how many minutes left? Okay, 5 minutes left. Let's see if we can finish this last one with 5 minutes. It's in a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities? There's no particular specific way of doing that. So what we're gonna do is to let's say for men, we have men and women in this committee. For the men, N is 5 men. And for the women, excuse me, N is 7 women. X, so it's a committee of 3 women and 2 men should be chosen. So for men, X is 3, And for the women, X is 3. Men is 2 actually. Men is 2. Okay, woman is 3. So how many different possibilities are there? So you have number of possibilities. Possibilities equals 5 combination 2 times 7 for women, 7 combination 3. That will give you the possibilities we're looking for. Okay. You can see this type. Are you going to start calculating this? I mean, there's nothing wrong with that, but to save time, remember this is statistics. And in the final exam, or well, the semester is very short. So you need technology to make to save time. Oh, excuse me. Can you see my screen?
Yes.
Yeah, 10 minutes left. So we have, let's do it and get our answer. We go to our calculator. Clear this. So first of all, we use parentheses to differentiate it. And then have, for men, we have 5 C2, 5,2. Okay, that is for men. Okay, times for the ladies, we have NCR 7,3. So you can see the answer right away. 350 weights. Okay. 350 weights. Questions?
And that, the way you just put that in the calculator, you had like double parentheses. That's how we're supposed to do it?
That's one way of doing it. Another way you can do it. Let me show you another way you can do it. Okay. You can get them separate. And then multiply.
And then add.
For men, 5,2. For men, okay, you can clear this. Men, 5,2, 5,2. That gives me 10. So I'm going to go and put 10 right there. Okay. 10 times. For women, I'm going to put 7,3. For women, 7, 3, 35. That's better, right?
Yeah.
35. I'll give us, multiply this to 10 times 35, 350 weights. Yeah, can do it that way too.
Okay, thank you.
Welcome. So we have less than 1 minute, so I'm gonna close up. Join us back here after 10 minutes, okay? So that we can finish up for the day. See you soon.
Okay.
Okay.